We are going to look at water. When you feel thirsty, definitely we'll look for a bottle of water. That means that actually water is very, very important in life. So in this presentation, we want to understand the chemical structure of water, what actually makes up water, and what properties does water have that actually make it very, very and a very important biological medium. Okay, so look at the roles that water plays and then relate those roles to the properties of water. So if you look at the cell, much of what makes up the cell is actually water. About 80% of the total cell volume is water. Water as a molecule, as a molecular compound, it has hydrogen and also oxygen making it up. And therefore, a simple chemical formula for formation, chemical equation for formation of water is that you get hydrogen and oxygen, then that's where you form the water. Okay, so you can say that the water molecule has oxygen and also hydrogen. Later on in the presentation, you'll definitely notice that we are drawing the hydrogen atoms at an angle to oxygen and not drawing it just like that. If you draw this is definitely not a water molecule. Okay, so that's water. So it makes much of what you find within the cytoplasm, or what we call the cytosol. It's very important for life. After we say that water is life, it plays a very important role in a number of chemical reactions that happen. So water is a polar molecule. One is a polar because of the charges that gives you the water molecule. So you have the hydrogen with a positive charge, and then the oxygen with a negative charge. So when you have a molecule that has both the positive and the negative charge, we say that it is the polar molecule. Okay? So what is this polar? And what does that mean? That means that if you have polar compounds, you will actually be able to dissolve in water. Okay, well, light dissolves in light. Since you say that if you have the polar compound, it will dissolve in the polar solid. Okay, so this negative and positive charge is best related to the distribution of electrons. That's why we have the oxygen and the okay, so the bonds that connect the oxygen to hydrogen are what we call the hydrogen bonds. Hydrogen bonds are formed when you have the electronegative ions being bonded to hydrogen. Okay, so oxygen electronegative, therefore has bonded to hydrogen, forming hydrogen bond. So we generally say that water is a universal solvent. It means that it is actually an excellent solvent. It can dissolve we have to use the one uniform solvent. This can imply that dissolve polar compounds. Explanation is what I did earlier on. I think it also dissolve ionic compounds or substances. So, for example, if you get salt, table salt, that is sodium chloride, when this ionizes, this is in a clear solution, it will give you sodium ions plus the chloride ions. Okay, in a clear solution. So this is an ionic compound, okay, and it dissolves in water. So this is to say that water contains ionic compounds. Okay, so the other property is that water has a high heat of vaporization. What does this mean? That if you want to convert water from liquid to vapor, basically gas, you need a lot of supply water with a lot of heat to vaporize, because you basically have to break the bonds, the hydrogen bonds, to make the water molecule free in vapor form. Okay, that's why you need a lot of heat. And what does this mean? This means that it's actually very important when it gets to sweating. So when you sweat, that that sweat evaporates. Okay, when it evaporates out of your skin, that's when you have cooling happen. Okay, but also the other thing is that you don't want to lose water to vapor organisms. If water had a lower heat of vaporization, then it would be very easy for the organisms actually to lose water. Okay, but since the heat of vaporization is very high, then you do not have an organism losing water very fast. So those are the importances of having a high heat of vaporization. The second point, or the third point actually, water has a high heat capacity. This relates to the amount of heat that is required to change the temperature of water by 1 degree centigrade. Okay. So, for example, if you have water, let us say 24 degrees. 24 degrees, and you want to change this to about, let us say, 25 degrees centigrade. The amount of heat that you need to raise that temperature from 24 to 25 is actually high. Okay, so that means that for the temperature of water to change, you need to supply significant heat. Okay, so even a small change in temperature requires a lot of heat. Okay, the first point is about having a high heat of fusion. Okay, the amount of energy that is required to convert ice, basically water, in solid form to liquid water, is actually very high. Okay, and therefore that is actually very important in maintaining cell structure. And then density at standard conditions, that is standard temperature, pressure, and density of water is 1,000 kilogram per cubic meters. Okay, and this actually is very important because you see, like in this diagram, that water is more dense than liquid water is more dense than ice, and therefore ice actually floats more. This is very important biologically because it means that even if you have ice on top, still underground you still have aquatic life. Organisms can still exist under the water, even if you have the ice on top. Okay. The other thing that you can also notice that you have these birds here actually standing on ice. Okay, and this ice is basically floating on water. Okay. And then we move to the second point, that water has cohesive and adhesive forces. And this basically relates to having high surface tension. So water behaves like in a way that the molecules are strongly attracted to one another. So it's like an elastic skin because of the bonds of attraction, the forces of attraction. Okay, and this is why you can have some insects that can actually move on water. Okay, you have seen this. This is because of surface tension, and that surface tension is because of the cohesive forces, the forces of attraction between water molecules. Okay, those are cohesive forces, and they're the ones contributing to high surface tension. Water is also transparent. This means that light can penetrate, and therefore organisms that are underwater that can perform photosynthesis can actually do that because they can access the sunlight. And then the other point is that water actually conducts electricity when it has dissolved the ions. Okay, if you have pure water, then you cannot talk about this. Pure water without any impurities, without any ions.